Today topic as assigned as transforming land management infrastructure through UAV, digital twin, and cadastral survey and geospatial infrastructure. It is great pleasure to be here. Some of the most transformative technology reshaping how we understand, manage, govern our lands and infrastructure. Today, we will explore the powerful synergy of UAV-based mapping, digital twin technology, cadastral survey, and overall national geospatial infrastructure. These are not the isolated innovation, they are interconnected piece of larger version of smart, efficient, and sustainable development. Before going UAV-based mapping, just I am highlight that history of UAV. Most of the audience present here known the history of UAV. This is the topic I am going through it. This is the preview history of UAV. UAV-based mapping, a new era in aerial surveying, digital twin technology, from static map to dynamic intelligence. Then fourth point, cadastral surveying, which is the foundation of land governance, and national geospatial infrastructure. And then integration and impact. This is the history of UAV. As you know, it is based on the principle of transmitting the command by radio signals. In the year of 1889, Nikola Tesla successfully demonstrated a model ship on the lake of Madison Square by remote control. Then the development of UAV is basically meant for defense purposes. After that, in 1975, companies were developed UAV in large scale for commercial purposes. The first country, Israel, developed UAV for capturing photographs for analysis purposes. Then UAV can be controlled. This is the continuation of the history. Can be controlled as you very much company people are present here, they are well acquainted. A drone consists of mainframes, landing gear, engines, propeller, etc. And I think the number of rotor is as on date is 8. Total as on date are more than 8. Then different types of rotor drone are there, fixed wing, multi-rotors, and vertical takeoff and landing drone also. And this is coming to survey drone. As you know that the drone survey is the digital photogrammetric for survey of small portion of the surface of the earth. Why we called as a survey drone? Because there are lots of drones are there, but the survey drones have some controller for taking the photographs, forward overlaps and side overlaps, also integrating with the GNSS receivers. That's why we are called as survey drones. This is the complete procedure of drone mappings. Mission planning, first we have to do the mission plannings through KML files, then IBS settings, then data downloading, whatever the pictures are taken by UAV, Then geotagging, processing the geotagging photographs and output like DM and orthorectified image, ORI. Then this is the output, orthorectified image. What is orthorectified image? Generally, drones are taking photographs. Then we have to process to obtain the orthorectified image, because every point looks as if observed from an observer. We are looking straight down at it along the line of sight, perpendicular to the earth. Orthorectification is the process of removing geometric error inherent within the photographs. Then what are the general geometric errors? Camera, sensor orientations, systematic error associated with camera, sensors, topographic relief and earth curvatures. These are the technical terms we are doing during the process of orthorectified image processing. This is the output, this is the raw photo, and this is the ortho photo. You have seen that wall, left side of the wall is slightly tilted. After orthorectified, this is in the straight line. Means we have to vectorize that wall also. Then based on Sir told that accuracy point of view, based on the orthorectified image, we have to measure the accuracy, RMSE, root mean square. Based on we have assigned certain parameter for X, Y and Z also for different type of surveys. And after that, we have to process for digital elevation models. What is digital elevation model? Image on which every pixel is showing an elevation, because every pixel have some heights. Then it is called digital elevation models. This is the 3D models. Just show that video clips, how it looks like. Video is not playing, I think. This is the back. Yes. Previous one. Previous slide. This one. First, we generate that 3D model of whatever the image we have taken from UAV. Then after 3D model, we have to vectorize this area also. We have to generate vectorized file also. Next. This is UAV based mapping, a new era of aerial surveying. As you know, drone have revolutionized the way of collecting geospatial data. Earlier, aerial survey was done by manned flight, and it is expensive equipment. Now, UAV democratizing mapping, making it faster, more accurate, and more accessible. Using UAV, we can capture high-resolution imagery, generate ortho photos, as I told, create 3D models, produce digital elevation model and digital surface models with remarkable precisions. This is also helpful for topographical surveying, disaster response mapping, construction and infrastructure monitoring, precision agriculture, cadastral mapping and land management. Generally, UAV bridge the gap between ground-based survey, satellite image, offering centimeter level of accuracy while being cost effective. This UAV based mapping is cost effective rather than aerial survey. Then these are the ongoing projects where Survey of India has already completed large-scale mapping survey of entire AP, Andhra Pradesh states, 1:5,000 scales. And Atal Mission Amrut 2.0 also it is going on. 2.0 means where town population is 5,000 to 1 lakh. And these are the output of AP resurvey, agriculture lands. Then coming to digital twin. What is digital twin? A groundbreaking concept where we can move from the static maps to living, breathing model of reality. Digital twin is a virtual replica of a physical entity, just like a city, building, utility network, or even entire nation's infrastructures. What makes it powerful is the ability to link the real-time data stream from sensor, IoT device, or UAV into these virtual models. Monitor progress in real time, simulate future developments, scenario, predict potential hazards or failure, optimize resource and uses. Now, digital twins are widely used in urban planning, transportations, utility management, disaster resilience planning. Then next is, this is the ongoing project which Survey of India is carried out, Naksha project. Survey of India is as a technical partners with DOLR, taking 152 cities for under this Naksha pilot project, where population is more than 1 lakh to 2 lakhs. This is the sample of the vector 3D models, output of Naksha. Then coming to fourth point, cadastral surveying. At the heart of the lands administration lies the cadastral survey, the detailed and authoritative of mapping of properties, boundary, ownership, and legal rights. It forms the legal foundation of real estate, taxation, urban planning, and conflict resolution. In traditional method, cadastral survey is very slow, manual, often inaccuracy. There is so much legal consequence for manual methods. Today, with the integration of UAV and GNSS or GIS or digital tools, we can modernize and accelerate the process. UAV provides us the GIS platform to manage, visualize, and legal frameworks to digitize land record also. So when you link the national digital cadastre, then it becomes a powerful tools for land reform, smart agriculture, infrastructure planning, and economic growth. And these are the activity done by Survey of India under cadastral survey. And this is the PPM draft of the PPM, and this PPM is ground verified. Then after ground verification, this copy is submitted to the owner, concerned owner. Then fifth point is national geospatial infrastructure, building a smart nation. UOB mapping digital twin cadastral survey lies on a robust national geospatial infrastructure. As you know, NGI is the backbone of any digital governance initiative. Geospatial data policy, special data infrastructure, national mapping agency, data standard, interoperability, open access platform or geospatial platform. As per UN GGIM, Survey of India is assigned 4.5 for creation of fundamental data set. Based on the fundamental data set, that user department can superimpose of any data, they can change. A well-developed NGI enables efficient land administration, informed decision making of all government levels, disaster risk reductions, climate resiliency, investment planning, and infrastructure developments. Based on the NGI, we have already taken up one of the district in Andhra Pradesh, that is Vijayanagaram district, under operation of Dronegiri, where all geospatial data from transportation, livelihood are integrated and accessed to the general publics. This operation Dronegiri is under progress, and it will be each and every data should be already in process, and already its aim is to given to public. And these are the effectiveness of the drone technology. On topographic mapping, that corridor or international boundary area. For canal mapping, longitudinal or cross sections. For mining purpose, volume estimation, got field and temporal volume. And agriculture, that yield estimation, plant count, segmentation, and also for 3D models, solar potential roof mapping for asset mapping purpose, and for like this feasibility, shadow analysis, railways, and hydrology, flood modeling, discharge modeling, like this. These are the advantage of drone technology over the traditional survey. Everybody talking that GST, this is the GST means ground sample distance, means size of the one pixel captured by the drone on the ground is minimum than the pixel size required other sources, which facilitate to measure the smallest element on the ground. So we have already completed one ICZM project under World Bank, which you have achieved the GST of 9 centimeter. But now in Swamit project, GST is 5 centimeter. This is the drone captured image. And the advantage of drone technology over traditional. You can see that this corner, this left side corner point is inaccessible for GPS observation. But we have already drawn 3 lines. So intersection of 2 lines, we can find out the third one inaccessible points. This is the advantage. For timely updation of maps, drone plays the vital roles. Facilitate of record of rights whenever ownership of the property changes. In the present scenario, ownership of property changing fast. To meet the requirement of the public, if minimum 2 UAV or drone are procured by taluka or a mandal level, any updation in property parcel map will be more easy and real time and also error free. And it also meet the need of the rapid urbanization and expansion of cities to maintain accurate land records, which also minimize the ownership dispute and lengthy legal battles. And these are the advantages. Now UAV are rapidly capture up-to-date data, digital twins simulate and optimize our real-world system, and cadastral survey formalize land ownership rights. These are the briefs. And we look to the future. Land is just not the terrain. It is our economic, our history, and our shared responsibility. Technology like UAV, digital twin, and modern cadastral systems supported strong geospatial infrastructure are the tool we need to manage this land wisely and equitably. Let's innovate and collaborate and map the future together.
Thank you for watching Drone TV, your gateway to the latest in drone technology, GIS innovations, and AI-driven solutions. To partner with us or promote your company on Drone TV, visit www.dronetv.in. Contact us at +917 5201 23555.